This project uses the form and sketch tools in Fusion 360 to design the general shape of a Mercedes 300 SL Gullwing, with its iconic sweeping headlights and the gently curved rear end. The car design utilizes the canvas feature in Fusion 360, with reference photos of the 300 SL added to serve as a visual guide. The form tool was employed to bend a flat plane into the desired shape of the car. Once the final shape was determined, insets for windshields were added to the front and rear of the car, as well as license plates added on the front and rear. The dimensions of these windshields were then transferred to Adobe Illustrator. Subsequently, the front and rear windshields were laser cut from acrylic and securely fixed in place on the vehicle. This step not only enhanced the aesthetics of the car, but also provided a smoother finish for the air to travel over, reducing the drag force experienced by the vehicle. While the shift in car shape over the decades from boxy styling to a sleeker round design has the advantage of improved aesthetics, the main reason for the change is the improved aerodynamics of the vehicle. More curved designs allow for the air to flow over the car with fewer interruptions, reducing the amount of turbulent airflow. To test the aerodynamics of the vehicle made, an experiment was the design that tested how the car performed in a homemade wind tunnel. An adapter was designed in Fusion 360 to take the vent of the humidifier and adapt it to fit a 1/4 inch hose, and it was also 3D printed. Next, a cardboard box was taken, cut in half, and then taped together again to be half the width, with an exhaust hole cut on the end using a circular cutter drill and a small hole cut on the other side for the 1/4 inch hose. The car was then placed inside the box and a final hole was cut for mounting the camera. Several locations were tested for the vapor hose to be mounted, as well as the addition of air from an air compressor to increase the flow. However, the final design attached the vapor hose directly in front of the car with no air compressor. The cardboard box was ideal for eliminating any air from the environment interrupting the flow. In addition, the dark lighting combined with the flashlight on the camera meant that the water vapor reflected the light, making it even more apparent how the air flowed in the system. As the angle of the flow was adjusted, the laminar flow coming out of the hose changed to turbulent flow as it passed over the rough 3D printed surface of the car. The curved front of the vehicle that sloped upwards slowly was ideal for limiting turbulence. However, the very rough surface of the vehicle increased the amount of drag, adding to the number of boundary layers. As the angle of the vapor hose was shifted to a steeper angle on the front of the car, the air moved across the front and up the windshield before going from attached to detached above the roof of the car, creating a very visible swirl of turbulence. The surface of the car could have been optimized to reduce drag by wet sanding the rough 3D printed surface. However, to mimic imperfections on most modern cars that increase drag, such as panel gaps, windshield wipers, grills, and license plates, the surface was left with its rough 3D printed finish. For the experiment, different hose diameters were tested to determine their impact on the vapor flow. It was observed that the larger hose diameter allowed for an increased vapor passage while reducing blockages, but caused by water vapor condensing within the tube. However, the downside to using a larger diameter pipe was less forceful airflow, as increasing the diameter of the pipe resulted in a decrease in pressure. The consequence of slower air flowing over the vehicle upon exiting the pipe would result in reduced effectiveness of the wind tunnel. Overall, the performance of the car matched expectations for a vehicle based on car designs in the 1950s, when proper wind tunnel testing did not yet exist. The purpose of the test was more to see how one could optimize a vehicle's shape and learn how to design the complex rounded shapes of the vehicles simply using readily available tools like CAD and 3D printing. I wanted to end by saying how much I have enjoyed hardware over the past 3 years, and how I know that the skills I have obtained in this class will prove to be invaluable in my future.